Okay, let me start and let them to join soon. Okay, as I said in the last lecture, I thought to finish the chapter number 2, but I feel something had remaining, so I would like to uh, include something in the chapter 2 itself. Okay, after that we can go to the chapter 3. So still we are in the chapter 2. Okay, so you can see our syllabus on that. You can see we have seen in our chapter 1 fully we have finished, and then in the chapter 2 we have finished first order partial differential. It's regarding the first order partial differential equation. In that self, I also doing the linear one, a linear one characteristic Lagrange equation on that one, and then our internet connections unstable. Okay, and the nonlinear one we have seen Chapit's method. Okay, and some characteristic strips and all. So in that Lagrange method, okay, so as well as the Chapit's method, so I would like to include some extra things in the chapter number 2. So let's continue the chapter number 2 itself today. So if it is finished, we can continue the chapter 3 later. So so in the last lecture, we have seen our type number 3 of multipliers. Okay, and as well as the type number 4 also, it's kind of a multipliers, but using the results again and things. Okay, so hope you all go through the lecture 6, and I'm going to start lecture 7 from here. Okay, put the heading integral surfaces passing through the given curve. So it's regarding the integral surface, the same kind of questions, but something like an applications. Okay, not like just like so far we have solved the equation of PDE. Okay, it's the quasi-linear PDEs of using the Lagrange's method, as well as in the nonlinear case we use the Chapit's method. So what if it is integral surfaces, something like applications, okay, which is involving some surfaces. Okay, so in that sense, the same method, a little bit of modification, we can use the same idea. So I'm not typed yet, so I will write the things. Okay, please copy me and write down the things. All right, so on that, consider, please write down the things. Consider we have the quasi-linear equation PP and QQ is equal to R. This is our quasi-linear equation number 1. Okay, so we have studied, we have discussed already how to obtain the general integral or general equation. Okay, general solutions of 1. So we know using the Lagrange's method and auxiliary equations we can use find these solutions. Here we are going to present the method. So there are 2 methods. I'm not going for 2 methods. I'm just gonna give you 1 method. Okay, that's enough. Here we are going to present a method of using such a general solution for getting the integral surface through through a given curve. Okay, so this is the introduction part of that heading. So please note down the things. We have discussed already how to find the general integral of 1. But here we're gonna present one method, which is using that general solution method for getting the integral surface through some given curve. Okay, so what if it is some extra bits with the equation itself? They're given something else which is, you know, passing through or cutting off this you know, curve or things. How we can solve this? That kind of thing we're gonna deal here. Okay, so I will continue the method. Okay, so let's go to the procedure. The procedure is, okay, this is the method, procedure or method. Okay, so what is this method says is, let our equation PP plus QQ, which is equal to R. I noticed some your seniors notes and all, they use for Q, they use G. So this is not the one. Q you have to write this way. Okay, so these are simple thing, but it should be there. Okay, so don't mess around these you know, notations. So let PP plus QQ plus R be the given equation. Given equation. This is what we have to solve. Okay, it's auxiliary equations. So this is a common thing we already discussed, but anyhow, auxiliary equations gives give the following two independent solutions. So as independent solutions. So we using the auxiliary equation. So what is the auxiliary equation? Dx over you know, u, like dy over v, dz over something, sorry, capital P, Q, R, isn't it? So in that sense, we will have, we can join two equation and we can solve. We will have two independent solution that we took as x of x pi, sorry, pi xyz, which is can be taken as C1, as well as chi of xyz, it can be taken as C2. This is our equation number 3. Let's have this one as number 1. I think already we have taken, so no problem. Yeah, let's continue. So suppose we wish to, so far we have known things. Okay, this we can solve using our Lagrangian method. Suppose we wish to find the integral surface. Okay, so integral surface which passes through, I hope you are copying with me. Okay, which passes through the curve whose equation in parametric form is given by. Okay, do you remember what do you mean by parametric forms? So in our vector calculus, so many lectures I have took for you, so it's very easy for me to, you know, incorporate the things, courses. Okay, so in the vector calculus also we have seen what is parametric form, like, you know, like if it is x, y, z, we use some you know, in terms of t, if we change this you know, variable in terms of some you know, parametrics of t, so it will change into this one, isn't it? So in that sense, okay, given by. So if we suppose we wish to find an integral surface which is which passes through the curve whose equation parametric form. So they are giving one of the curve, okay, which they say this equation is passing through these equations, then solve it. Okay, in that sense, so we have if they give parametric form, we have to use it, otherwise we have to change it. Okay, All right, so given by like x equal to x of t, we are changing x equal to x of t, y is equal to y of t, as well as z is equal to z of t. Okay, where t is a parameter. Okay, here we are taking t as a parameter. So my writing is not neat, but anyhow, you can copy now. So t is a parameter. Okay, let's continue. Okay. If you are slow, please take a screenshot of my windows. Okay, now see the this is equation number 2. We're gonna use the parametric in that solutions. Okay, so if so, the solution will be changed into, okay, our second equation will change as phi of let's say x comma t, y will be changed to y comma t, z will be z of t, okay, which is equal to c1 again, and chi also same. Okay, x of t, y of t, or z of t. You can use any brackets. Okay, I'm just using this. Okay, let's take this one. Yeah, let's say 3. Okay, now we sorry. Now why I couldn't write. Okay, give me a second. We eliminate single parameter t from equation 3 and get a new relation involving C1 and C2. Okay. Now we eliminate single parameter t from the equation 3 and get a new relations involving the C1 and C2. Okay. Then finally, we can see in the examples. So finally, we replace C1 and C2 with the help of number 2. Okay. And obtain the required integral surface. Okay. So this is the procedure. So we eliminate the single parameter t from 3, equation 3, and get a new relation involving C1 and C2. And then finally, we replace C1 and C2 with the help of number 2. It means pi and chi, and obtain the required integral surface. Okay. So this is our method to solve this. There are some method 2 and 3 there, but I'm not gonna go to that. Okay. Okay, let's do one example so you can understand this. Okay, example. Okay, I'll show you the question so you can copy down. Okay, this is our example. No need to copy the solution, just write down this example. this one. Find the equation of integral surface 2y z minus 3p plus 2x minus z of q is equal to y times 2x minus 3, which passes through the circle that is equal to 0, and this is like this. Okay, sorry. Should be x square plus y squared is equal to 2x. So you know this is the equation of circle. Okay. Also they say that is equal to 0. So in this kind, the equation will come this way. Not only the equation to solve, but also some extra things to consider, like passes through some curves and all. So this is how you have to do the same process but extra something. Okay. Okay, let me solve this one first of all. Okay, can you mute? Somebody has 152. Can you mute your mic? Okay. So let's start our exam solution. Okay. Okay. Solution. The simultaneous. So this process we already know from the Lagrange's method. Okay. The simultaneous system associated with linear PDE. You can find that the equation is a linear one. Okay. So the simultaneous system associated with linear PDE is dx over 2y. So dx over p, no? Z minus 3. Okay. Which is equal to, so that the equation in the form of pp plus qq is equal to r, like a linear, quasi-linear equations. Again, dy divided by the q term is 2x minus z. Give me a second. Yeah, 2x minus z. Yeah. Then dz is equal to y times 2x minus 3. Is that correct? 2x minus. Is this correct? Yes, no? Okay. Now let's solve this using our, ordinary way. Like, let's take these two fraction. Okay. Taking the first and second fraction. So whatever you are doing, you have to give in a one sentence. So then only we know. Rather than just doing the calculation, just give some word. It's not like a paragraph. It just write something. So I'm gonna take these two, first and second fraction, like that. So in the exam also, if you like that, it is very easy for the corrections. You will get some extra marks and all for that. Okay, so I can I think, yeah, I made a mistake here. Sorry, not first and second. I think first and third. Okay, let's Is that possible? No. Okay, I think in the questions, okay, please change the question like this because the answer has some different way. 2y z minus 3 of, sorry, give me a sec. Of p, that is okay, plus should be according to their first and second fractions, because this that is involving here, no, so there is a small mistakes happen. Okay, give me a second. Okay, 2x 2y. Okay, let's take third. Okay, first of all, let's take first and third. So can I do this one? First and third. Okay, this and this. So you can see dx over 2y z minus 3, which is equal to dz over, okay, y is cancel out, no? So no problem. Okay, so dz over y times 2x minus 3. Okay, now fine. So y and y we can cancel out. So when you cross product this one, you will have 2x minus 3 of dx, which is equal to 2 times z minus 3 of dz. Okay, yes, that's fine. Okay, now can you integrate? So integrating, what you'll get? Okay, so if you integrate with respect to both sides, so you will have okay, for 2x you will have x squared, isn't it? X squared by 2, and then 2 and 2 cancel out. Okay, minus for this one you will have 3x, okay, which is equal to, for this one, so I think you are okay with the integration. Okay, so I don't need to explain this much. But if you are not confusing, you just write down, you just write like this: 2x dx minus 3 dx is equal to 2z dz. So it's okay also. Okay, you can write like that, and you can write the integration. After integration, you can write integration this one, sorry, this one, and you can take what is integration of 2s, sorry, integration of 2x of dx. So for the 2 you can take out, and x you can have x squared by 2. So 2 and 2 cancel out. That's why x squared. Okay, so hope you are good at the integration. So I'm going. I'm just solving quickly. Okay, 2z also will be z squared. This will be 3z, no, 3 or 6z. Is that? Yeah, 6z. So if you take this side, you will have x squared minus 3x, okay, minus z square plus 6z, which is equal to, let's say, c1 plus c1. You can write c1 here. Okay, where c1 is an arbitrary constant. Okay, so let's take this one as number 1. Okay, equation number 1. Okay, meeting gonna end in 10 minutes, so it's okay. So yeah, sorry about this one. This will be 2x minus z. Okay. So what else you can take? Can you take? So I have taken this and this. Okay, this is correct. Okay. So balance is either I need to take this one or these two. Okay. See the difficulties in this. In I taking these two. Okay, x there, y there, this x there, but z also involving no. So that will be a different case. So similarly, if you have this and this, so that is going to type 2 or 3. You can try that one anyhow. But I'm going to try the type 3 and that things, okay? So here also you can see X also involving, but here we have Y and Z only. So it just goes to the type number 2 and things. So rather than doing that one, I'm going to, because I only got the C1, I need to get the C2 also. So I'm going to go for the method. Let's take our type number 3. So multipliers. Okay. So I'll continue. If you need, please take the screenshot. Okay. So now I'm going to do for my C2, I'm going to choosing what are the multipliers you can choose. Can you find out to get our denominator 0? So that is our type 3, no? Type 3, we have to find a multiplier to get our denominator is equal to 0. Then the numerator also will be 0. Okay. So you can see our denominators are 2yz minus 3. Okay. So, and 2x minus z. And then y times 2x minus 3. See, this is how you have to, find the multipliers. You have to choose, okay, y is that there, 2yz there. So where I can find the yz? This is 2xy. Okay. So if I if I have here, okay, y, okay, let's take y. If I take y, what you'll get? Y is 2yz. Here only I have plus yz, no? So I need to get plus here. Okay. So yz, yz. But here I have 2, no? Okay, let's keep that one. We have something wrong. But here I have 2xy. Here 2xy. Then this one is fine. So I need to use minus. Okay. Then I have plus 3y. Here I have minus 6y. So something this 2 is bothering now. So what I need to do is, and I can use my multipliers half. Okay. So first half, then y. Here I didn't multiply anything, so minus 1. So see, this is how you have to take some time to choose your multipliers. Okay. So now see the things 2 and 2 cancel out. So yz, here I have minus yz. Okay, fine. And then here minus 3y. Here I have plus 3y. Okay, that's also fine. Then I have 2xy. This also minus 2xy. Okay, all are zeros. Okay. So this is how you have to find the multipliers. Okay. Take some time to analyze the things. So I will get here half of dz dx plus y of dy minus dz. Okay. Write down this one here and then write this. Okay. I'm just lazy. So you write down this and this one here. And after that only you have to show this is equal to 0. Follow the rules. Okay. So you go with the steps. Okay. Now. So from this, I know if my denominator is 0, my numerator should be 0 according to the rules of type number 3. Okay, then I have y dy minus dz should be equal to 0. Okay, then if you integrate again, you will have, okay, half times, okay, there's nothing. So x, this will be y squared by 2. This will be z. So I have my C2. So since of by 2, I can use C2 by 2. Okay. So if I simplify this one, take out all the, half. So x plus y square. So I need to cross product this one, 2z, which is equal to C2. So this is my second equation of C2. Okay, this is the answer for the question. The equation itself. But here we are not only solving our equation, but also including some curves, isn't it? So they say this integral surface will be passes through the circle. So we have to go to the next steps of parametric and all. Okay. Okay, I'll continue the things. Okay, now let's take the steps to take the integral surfaces. Okay, since the integral surface that given surface has to pass through what? Through the circle, no? Pass through the circle. They already given the equation of circle. X square y square is equal to 2x, as well as that is equal to 0. Okay, so yeah, so what I'm gonna do is I'm gonna incorporate this one, because I have x square here, 2x, but actually our circle equation will be something like x minus a whole square plus y minus b whole square is equal to 0, no? So 0 or r square, okay, c square, yeah, sorry, r square. So here my centers are a comma b and r is a radius, okay, center, okay. So this is our circle equation. So they have given us x square y square 2x. So this is not in the form of this one, no. So we're gonna make it, okay, we're gonna make it into that form. So how I possibly make it? So x squared, and if I take 2x here, that will be there. This will be, let's say, 0. Still I'm not having anything. I don't have the r. So still this is not in the form. So if I wanted to make this form, okay, so what I can take? So x squared is there. So x, this one minus, okay. What I can put to make it a square? Can you find out? So in that sense, this is also will change. Can you give this, equation? I want everyone to answer me. This is just school level of maths things, no? So make it as if this square form, and the y squared, okay. Because of you are taking something, it will change also. So what is our actual equation? Okay, give me the full equation. This entire equation. Can you give this entire equation? So you know these things, no? X squared there. So what is a minus b whole thing squared? A minus whole thing squared will be a square minus 2ab plus b square. So in that sense, you have to add and subtract something. That subtraction will go this side. Okay, so that's what happened. So can you find out this equation? I want at least 5 to 10 people to answer. These are simple things. If you know these things only, you can, deal these questions. Yeah, good. 005 correct. 129 correct. 77 correct. Okay, good. What about others? 003. Can you check your RHS part? Yours correct. LHS part correct. RHS wrong. And 093. Can you